One agent, 5 frameworks side by side. Let's see exactly how they compare and which framework fits the way you want to build. In this demo, each framework runs in its own isolated container with its own dependencies and its own requirements file. They all connect to one shared MCP server, and everything is wired together into a single runnable stack with Docker Compose. Then all of it feeds into one shared web app that powers this comparison UI. This is a single agent comparison on purpose. I wanted to start with a clean baseline first, then do a multi-agent version in a future video if you guys want to see that. So here's the lineup: Crew AI, LangGraph, LlamaIndex, Microsoft Agent Framework, and Pydantic AI. And it's worth noting that I'm using LangGraph here instead of LangChain because it gives us the lower level framework layer for a cleaner side-by-side comparison. Okay, so our demo agent is a flight assistant simulator, and it can check weather information, get fare types, look up refund policies using RAG, and call booking actions through MCP. Now, we're going to use dummy data across the board for the demo, but the structure would be the same with real APIs, data sources, and MCP servers. Let's look at the agent setup, how each framework defines the agent before it runs. For Crew AI, we first set up our model, and then we can create our agent and pass the role, which is what it's supposed to be. So a flight assistant simulator, and then a goal, a backstory, and we can pass our model, tools, MCPs, and then I'm using a couple of optional parameters that we're not going to touch on right now. Okay, for LangGraph, we also start by defining our model. So I'm using Chat OpenAI, and we can pass model name, API key, temperature. And then we create the agent by calling this create react agent function, which takes these parameters, so the model, tools, prompt, and then it converts everything to the agent itself. In LlamaIndex, the agent is set up by calling this function agent function, and then we can pass our tools, LLM, and we can set it up by calling the OpenAI, passing the model API key, and callback manager here is used to set up some logging for our application. And then we also pass the system prompt. Microsoft Agent Framework starts by creating the model client with OpenAI chat client. Then we call as agent, which turns that into an agent by giving it a name, instructions, and tools. Okay, for Pydantic AI, we start with the agent object itself. We pass the provider and a model name, and then a system prompt and tool sets. And we can use tool sets when we have a collection or a bundle of tools. And this is the case usually with MCP. So I'm passing the MCP tool sets here. And for my plain tools, like these ones, we can just assign them to the agent directly like this. So that's the setup step in each one. We define the model, the agent, give it instructions and tools, and get it ready to run. Now let's take a look at tool calling. And tools are how the agent does things, like checking the weather or getting the fare type. In Crew AI, tools are normal functions marked with the tool decorator, and we're giving it an explicit tool name. Then we pass our tools, so we have weather check, lookup fare type, and search knowledge. We pass those tools right here onto the agent. So that way the agent has access to these tools. So for example, if it needs to check the weather, now it can use this function, which is right here, to do that. Then in LangGraph, tools are also just Python functions with the tool decorator. Then again, we pass them to our create react agent function through the tools list, as you can see here. And then this agent also has access to these tools, including the MCP tools, which we're going to see in a few, whenever it needs to call any of them. In LlamaIndex, these start as normal Python functions as well, but then we call function tool from defaults, which turns them into tool objects. So we pass the function, and then we can use this tools list right here when we're building our agent. In Microsoft Agent Framework, the tools are async functions too. But here the inputs are typed and described with annotated and field. And then we can pass those functions into tools right here, which is inside of as agent. So then they become part of the agent setup. In Pydantic AI, we can see that we're not passing any tools within our agent setup. That's because the tool registration happens directly on the agent with agent.toolPlane. So instead of collecting tools in a separate list first, each function gets attached right onto the agent like this. So across the board, the main idea is pretty similar. Define the tools, then give the agent access to them. Now let's look at RAG. Tools are actions, while RAG, retrieval augmented generation, is for searching documents, files, or saved information and adding the useful parts into the prompt as extra context. This gives the large language model more information when you need to ask it about specific things like internal documents or things that it doesn't have access to. Okay, so we have this search knowledge function for all the frameworks, and this search knowledge function implements RAG, which means that this function, given a query, can look into external resources, in our case, this markdown document, and it can extract similar information to that query. So in our case, we have a bunch of rules here about refundable fares. Basic is non-refundable, standard is 50% refundable, flex 100%. So if a user queries the model and says, I have a basic fare and I want a refund, then this function implementing RAG is going to look for basic fare, right? And it's going to add this to the model's prompt so that the model now knows that basic fares are non-refundable. So it's going to reject this request. In Crew AI, the tool that implements RAG is, again, just a function. So we pass this tool, we decorate it with tool, and then we give it a name, and we can pass it just like we did with other tools. So we have our weather check, lookup fare type, and search knowledge, which implements RAG. And this is LangGraph. Here, it's exactly the same thing. So we have our search knowledge, and this is just another tool. We can add it right next to other things like our weather check, lookup fares, and later we're going to see our MCP tools. In Llama Index, and even though retrieval is a huge part of the framework, we're just keeping it simple for this demo. RAG still shows up as a search knowledge function like we saw with Crew AI and LangGraph, and we can pass it right here within our tools list with the other functions, weather check, and lookup fare type. And this is exactly the same thing for Microsoft Agent Framework. So this is our tool, this is our function here, and it's in the tools list. Again, search knowledge is a function within Pydantic AI, and we just attach it to the agent by using this decorator agent tool plane as we saw before. So across all 5 frameworks, the main idea is the same. Retrieval through RAG uses a tool or a regular function that searches the knowledge sources. Now let's take a look at MCP, often described as the USB-C of AI, because it gives agents a standard way to connect to outside tools. I'm going to use the HTTP or streamable HTTP MCP setup in this demo. MCP can also work in other ways, but I'm not covering those here. Since the demo MCP server is running over HTTP, this gives every framework the same connection path and keeps the comparison clean. So with Crew AI, MCP starts with MCP server HTTP. This is where we pass the server URL, and I'm also setting streamable to true to use the streamable HTTP MCP transport. And I'm setting cache tools list to true. This is so Crew AI can reuse the discovered tool list from cache. Then that server object and this array or this list, we can pass it here to the agent through MCPs, and we just say MCPs equals MCP servers, our list here. Okay, so for LangGraph, we're setting transport to HTTP and we're passing our server URL here. Then we're using this tool interceptors log MCP call, which is just a hook around each MCP call. So for this demo, we can log and display what tool got called in the demo UI that you saw at the start of the video. Then we can call this getTools method on this MCP client, which returns the discoverable tools from this MCP server. And then we can just pass the tools, MCP tools here, to the tools list when we're creating our agent using create React agent. For Llama Index, basic MCP client is the built-in piece that talks to the MCP server. My custom class logged MCP client here just adds logging on top of that, so we have something to show for the demo UI. Then we create the MCP client and we call MCP tool spec, which turns that MCP connection into tools for the agent. Then we call this function to tool list async, which pulls the tools out from the MCP server as a normal tool list we can pass to the agent. So we're saying tools, and here you can see our MCP tools that we just got. For Microsoft Agent Framework, we kind of have the same thing that we saw with Llama Index. So I have a custom class here that uses MCP streamable HTTP tool, And the reason we have this is because we want to add some logging to the comparison UI that we're going to see at the end of this video. So then we create the actual MCP tool that connects to the shared booking server, where name is just a label, and we pass the server URL. And then we do this async with MCP tool, which opens that connection while the agent runs. In Microsoft Agent Framework, we have to make sure that the MCP server tool connection is open so that the agent can use the tools from this MCP server. Okay, in Pydantic AI, we have MCP server streamable HTTP. And the first argument is our server URL. Then we have this process tool call, which we set up here as a wrapper to hook around MCP tool execution. And this again, we need to do this just to log the calls so we can show those in the demo UI. Then we pass this MCP toolsets to the agents toolsets list here so that the tools from the server are available to our agent. So again, similar patterns across the board. We have to connect to the MCP server, grab the tools, and add them to the agent so that it has access to the list of tools coming from that server. And in this case here for this demo, we have this server, which is a demo server, with one tool called refund booking, which always returns true. So if someone queries our agent and says, I have a fare that I want to refund, the agent is supposed to call this tool, refund booking, to execute the refund. And in every case, that's going to return true. Now let's take a look at the execution flow, which is how each agent actually runs. In Crew AI, we create the agent first, as you saw, then we wrap the prompt inside of a task. And this task is made up of the description, which is the prompt, an expected output, and we assign it to our agent. And then we put everything inside of a crew, which is made up of a list of agents and a list of tasks. In our case, we have just one agent and one task. So once we have this crew, we can run it by calling kickoff async and then passing the prompt. In LangGraph, and since we have just one agent, we can run it by calling agent.ainvoke, and then we pass in the user prompt right here. And after this runs, the result will contain a list of messages where we can extract the final answer from that list. Llama index, straight to the point, we just do agent.run, we pass the prompt, and we're good to go with the result. Going back to Microsoft Agent Framework, we first open up the MCP tool connection with async with MCP tool. Then we can call the agent.run function and pass the prompt. Finally, we can read the final answer from result.txt. And finally, in Pydantic AI, the run step is very direct. Just like Llama Index, we can do agent.run and we pass the prompt. Then the output comes back on the result. Okay. Now let's look at the results side by side, including speed and token usage. I'm going to say my booking ID is ABC123 and I'm flying from Montreal to Vancouver tomorrow. Please check the weather, and if it's bad, process the refund for my booking. Now, what I'm saying here, take this booking ID, get the fare type using fare lookup, and then check the weather using the tool. And if the weather is bad and my fare type allows a refund, process the refund. This is going to use a tool to get the fare type. This is going to use a tool to get the weather. And here, the agent should know to check the refund policy using RAG for this fare type. Okay, so if we have a basic fare, there's no refund. If we have a flex fare, we have 100% refund. And then we're saying process the refund for my booking. And if this is eligible for a refund, this process, the refund for my booking, should call the MCP server, which has a refund function that always returns true, if you remember. Okay, so I'm going to run this and let's see what we get from the agents. Okay, first, if we look at the speed, we can see that Microsoft Agent Framework came out on top with about 4 seconds to run this query. In terms of token usage, LangGraph came out on top with 531 total tokens used, which is more efficient than the other frameworks. Now, I have to say that these values aren't always in this order. Even if I run the same prompt again and again, these will sometimes change. However, I just want to note that LangGraph is almost every time the most efficient one in terms of token usage. That's not the case all the time, but a lot of times. Okay, let's see what we have. So For Crew AI, we got a steady rain weather. So we might have delays. Your booking fare type is basic, which according to the refund policy is non-refundable. So this is our RAG. And this is our function call. And then a refund cannot be processed. That's fine because it's non-refundable. So it's not going to call the MCP tool. As you can see, we have 2 tools here, 1 RAG, 0 MCP. Let's see what happened. So this is our input, weather check, rainy. And then we got lookup fare type. We have ABC is basic fare type. And then we have RAG to check the policy, refund policy for basic fare type. And now the model knows not to refund this, even if the weather was good. Let's see what happened with LangGraph. Okay, so here we have good weather. So we have sunny weather. Also, your booking fare type is basic, which is non-refundable. Therefore, I cannot process a refund. Okay, so we have 2 tools, 1 RAG, same thing. The only difference here is that the weather returned sunny instead of, I think we had rainy here. Yeah, okay. So that's the difference. The other calls are the same. So we have RAG. Okay, that's perfect. Now let's see Llama Index. So I have stormy conditions, thunderstorms, non-refundable, perfect. 2 tools, 1 RAG, same thing. Microsoft Agent Framework has 3 tools. So we have a clear weather. Your fare type is basic, non-refundable. We have 3 tools. So let's see. Okay, so the weather check was called twice, 1 for Montreal and 1 for Vancouver, which is okay, that's good. For other frameworks, the weather check was called once for both cities. Okay, that's fine. Now let's see Pydantic AI. The weather is stormy. So anyway, the weather is bad. I need a refund. It's basic, non-refundable, perfect. 2 tools, 1 RAG, so everything works perfectly. Let's go and change this to 5. And 5 is going to return a flex fare, which is fully refundable. I'm going to run this again and let's see what we have. Okay, so speed, Microsoft Agent Framework, tokens, LangGraph. Let's see Crew AI first. So we have a storm, a flex fare, which qualifies for 100% refund. I have processed the refund of your booking. And by processing the refund, we can see this 1 MCP call. So if we go down, we have the same thing as before, except this time, you can see this MCP tool call, which says input is booking ID 5 and then is done true. That's always going to be true as we saw. And yeah, we can see here the RAG, which says flex fares are eligible for 100% refund. The answer makes sense. I'm going to move to LangGraph. Here we also have delays due to weather and flex fare, full refund. I have processed the refund. So we have 1 MCP call again. Let's go down. Okay, perfect. So we can see is done true as well. Cool. Now let's see Llama Index. Same thing, steady rain with possible delays, flex fare. I have processed the refund. Perfect. We can see the MCP call. So that's the same thing. Is done true. Okay. Microsoft Agent Framework, stormy. I have processed the full refund. Now it's deciding to use weather check with both cities as the input. That's fine. 1 MCP call, perfect, which is refunding the booking. We also have bad weather here. So Pydantic AI also used the MCP tool to refund this booking, which is perfect. Let me try one more time just to see if I get a sunny weather. That way we know that a refund is not needed, even though we have a flex fare type and we asked for a refund. So no MCP calls should happen. Okay, so here we have windy conditions, moderate risk, delays, crosswinds. Okay, so we can see the cancellations happening by looking at this 1 MCP here. We know that the refund, sorry, not the cancellation, the refund took place. So same thing here. Okay. We can see 0 MCP calls here with Microsoft Agent Framework and Pydantic AI. I'm guessing that's because we have a sunny weather. So let's see. The weather is sunny with low disruption risk. There is no weather reason to refund your booking. Since the weather is good and there's no disruption risk, would you like me to process? So it's checking first because the weather is good. And I asked it specifically if the weather is bad, process the refund. Same thing is happening here, sunny, and your fare type is flex, which qualifies. Okay. However, since the weather is good and there is no indication of service issues, a refund is not necessary. Let me know if you want to proceed. That's exactly what I wanted to see. So I made this video to show you what setting up the same single agent looks like across these frameworks. and hopefully help you figure out which one feels right for you the way you like to build. And honestly, depending on the problem you have, you might not need a framework at all. If you want part 2, where we do the same exact thing with multi-agent setups, let me know in the comments.